Good day and welcome to 501 Math where we work smart, not hard. In today's problem, we're given this diagram of a trapezium with a circle inside of it, and the only information we're given is the two parallel sides are 3 centimeters and 7 centimeters. With that, we're to determine the radius of the circle. Pause the video here, give it a try, see what you come up with. I'll be solving it two ways. So let's first begin by identifying the radii of the circle on the diagram. By definition, the radius is the distance from the center to any point on the circumference. So we have many that we can identify. That's 1, that's 2, that's 3, and in particular, that distance there at the bottom is also 4. Next, let's see, at the top, that distance there, what will that be? Well, if the entire distance is 3 and on the left is r, that distance will be 3 minus r. This little distance in red will also be 3 minus r. Why is that the case? Well, according to our circle theorem, any two tangents to a circle that start from the same point, those are going to be equivalent to each other. So both of those are 3r. Moving on, at the bottom, if the entire distance is 7, then that distance in red will be 7 minus r. And similarly, that distance there on the other side is also 7 minus r. The same circle theorem as from before. So simplifying, that will give us 10 minus 2r. 7 and 3 is 10, minus r is 2r. Continuing, this entire distance here on the left, which is the vertical height, that will be twice the radius. That will also be the same in that side there over to the right, where we see a right angle triangle. At the bottom, that side in red, that will be the complete distance of 7 minus the 3 at the top, which leaves us with 4. So we now have a right angle triangle and we can use Pythagoras Theorem. So the square of 4 plus the square of 2r will be equal to the square of 10 minus 2r. 4 squared is 16. The square of 2r is 4r squared. Simplifying, we'll have 100 minus 20r plus 4r squared. We see that we're adding 4r squared on both sides, so we can cancel that and simplify the minus 20r and minus 20r, which will give us minus 40r. Transposing, we'll have 40r is equal to 100 minus 16, which is 84. So r will be 84 divided by 40, which is 2.1. Did you get it right? If not, let's see another way we can work it out. So previously we knew that this distance is 7 minus r, as well as that one. That's a radius, that's a radius, that's a radius, and those are both 3 minus r. Why are we looking at those? Well, we can see here that technically we have a little kite, and in particular this kite is exactly the same as that big kite, but just a scaled down version. So we have similar shapes. According to similar shapes, ratios of corresponding sides are in the same ratio. So that means that the long sides to the short sides of both kites are the same. In particular, the long distance of the big kite, 7 minus r, compared to r, is equal to the long distance of the small kite, r, compared to 3 minus r. We can transpose and cross multiply both sides. So we have that r times r is equal to 7 minus r times 3 minus r. That will leave us with r squared is equal to 21 minus 7r minus 3r plus r squared. We're adding r squared on both sides. We can cancel those, and simplifying, we'll have 0 is equal to 21 minus 10r. Transposing, we'll have 10r is equal to 21. Therefore, r will be 21 divided by 10, which also gives us that r is 2.1 centimeters. Did you get it right? If so, comment below. And as always, if you found this video useful or you liked it, please hit that like button, share with others, and subscribe if you're new here.